Good morning. Welcome back to our channel, AfriEdu, where we will be solving mathematical problems. Uh, Today, we are going to be concentrating on the parabola, the quadratic function. So, in this exercise, we are given this question. It's saying express 2x minus 6x, 2x squared minus 6x plus 3 in the form a, open bracket, x plus b, close bracket, squared plus c. So if you check this, it's a form that we expect to get when we complete the square. So one method that we can do to answer that question, it simply means they are trying to say complete the square of this quadratic expression, complete the square of this quadratic function. So we are given 2x squared minus 6x plus 3. So it therefore means that here, when we are completing the square, always make sure that the coefficient of x squared is unit. So how do we do that? We have to factor out whatever is the coefficient of x squared if it's not unit. Therefore, we are going to have x squared minus, here it's going to be 3x plus the 3 over 2. Here what we did simply means when we factor out 2, we divided every term by 2. So we are now having this. From there, you had to add, okay, this is step. Then from there, we have our 2 bracket, we have x squared minus 3x. So to make that a perfect square, we have to add half the coefficient of x squared. So half of the coefficient of x is negative 3. So half of that is negative 3 over 2, that squared. But this thing we added, it was not there. Let's take it off, which is going to minus 3 over 2 squared. Then we take that plus 3 over 2, which was originally in our question. So this is what we now have. If we are to check this part, yeah, it's now a perfect square. So it means this becomes 2, open bracket. Then we are going to have x. Let's use a box bracket there. Let's use a bigger bracket. So here, this underlined part is now a perfect square. This one becomes x minus 3 over 2, open bracket. We square that. Then we simplify that part which is there. So it's going to be minus, when you simplify that, it's going to be 9 over 4 plus 3 over 2. Simplify that, it's going to be equal to 2. We have a 2, the pen is misbehaving. Then bigger bracket. So we are going to have here is x minus 3 over 2 squared. When you simplify this, it's going to be minus 3 over 4. We are saying minus 9 over 4 plus 3 over 2. We can simplify using your calculator, then you get that. Then let's multiply by 2 in this to remove the bigger bracket. So this reduces to 2, open bracket, x minus 3 over 2 squared. Then let this 2 multiply this term outside, minus 3 over 2. This becomes our answer. And can you please take note there? That is one way of doing it. Alternatively, you can decide to use identities. If we are using identities, you just take this part where we want to go, then let us expand to remove the brackets. If we are to expand this part, it means it's going to be a open bracket. Then when we expand this part, it's going to be x squared plus 2bx plus b squared, close bracket, we have a plus c. Then we are going to have a x squared plus 2a b x plus a b squared plus c. This becomes our expanded form of this part. So this part which we have expanded is identical to the given expression, which is 2x squared minus 6x plus 3. From there, you compare the two. If we check the coefficient of x squared, since those two are the same, on that they are written in different forms, it means the coefficient of x squared here must be equal to the coefficient of x squared. So we can conclude that our a is equal to 2. Then we move to the next. We want to check our coefficient of x. Here our coefficient of x is 2ab, so we can now say 2ab must be equal to the coefficient of x there is minus 6. Here we are taking this, the coefficient of x here. There is the coefficient of x here. So we divide both sides by 2. We are left with our AB being equal to minus 3 after we divide that by 2. But we know our A is equal to 2. So if we divide by 2 both sides, in other words, if we put 2, we are saying 2b, because our A we found it there is equal to minus 3. If you divide both sides, it means your B is equal to minus 3 over 2. Then to get our C, we take the constant, the terms or the term without an x. In this case, this is the part without an x, which is a b squared plus c. That part must be equal to term without an x here, which is that one. It's a 3 there. But a, we found our a to be 2. Leave it that way. Then our b, we found our b to be 3 over 2, which is negative there. If you square that plus the c, that must be equal to 3. But if we check this, we can simplify it. We will have 2, then that one, it becomes in bracket, we have 9 over 4 being equated to it's 9 over 4. Then this, we have a plus c being equated to 3. Then if we are to check, simplifying here, it becomes 9 over 2 plus c being equated to 3. Then we transpose the 9 over 2, leaving the c alone. So it will mean that the c here will be equal to 3 minus 9 over 2, which gives us minus 3 over 2. Then from there, It therefore means that since we now have A, we have B here, we have C here, we can write that. So writing that in the form which they want here, our A, we found it to be 2. So it means this reduces to 2. Then we have open bracket x. Our B, we found it to be minus 3, which gives us minus 3 over 2, which is our B here. Take note, squared. Then it's having plus C. Where is our C? Just come, our C is minus 3 over 2. It's going to be saying minus 3 over 2. Eventually, it means this term, which is here, will reduce to this term, which is here. Then conclusively, if you are to check this term, which is written here, it's a standard quadratic expression, which is in the form ax squared plus bx plus c. If you check this term here, it's a standard quadratic equation, which is written in the form here, a, open bracket, x plus p squared plus c. But in this format, if you want to get the coordinates of the turning point, we know at turning point your x is equal to minus b over 2a. Then once you get the x coordinate, to get the y coordinate, substitute it in this form so that you get the corresponding y coordinate at turning point. The a here and the a in this format, they represent the same thing. Now when you come to this format, if you are asked the coordinates of turning point, it means to get the x coordinate, you equate the part in the bracket here to 0. We're going to say x plus b is equal to 0. So it means the coordinates at turning point, we are going to get minus b. Then this part which is outside forms the y coordinate, which is c. So if we are to check now, using that format, compare our understanding of those two formats, it means another way of calculating those coordinates there. So this is the another alternative way that we can use to do that. It means using that format of what we are given, we were going to check what is the x coordinate at turning point. So it means x at turning point is equal to, from the formula which you said minus b over 2a, is going to be minus, but what's our b? Our b is negative 6 there. All over 2a, what's our a? A is the coefficient there. So of x squared, 2 here. So if we are to check punching this on your calculator, we are going to get this to be equal to a 6 divided it's going to be 6 divided by 4, which gives you 3 over 2 here as the x coordinate. So it means we now have the x coordinate at turning point. When you now want the y coordinate at turning point, substitute this in this function. So we are going to let y to be equal to that. Let y be equal to that. So our y is equal to 2x squared minus 6x plus 3. Then you substitute the value of x coordinate at turning point. So it's going to be 2. At turning point is going to be 3 over 2, the value of x, squared minus 6, the value of x there is 3 over 2 plus 3. Then from there, it means you can punch this on your calculator. If you punch this on your calculator, you are going to get the value of x to be equal to a negative 3 over 2. So you now have the x-coordinate at turning point, you now have your y-coordinate at turning point. It therefore means that when you now write this, you can now write this in this form, the turning point form. So your A in this form and in this form will be the same. So it means that reduces to 2, open bracket. Remember, our x-coordinate turning point is this, but when you want to, the factor that we solved to get this value, it means it's going to be x minus 3 over 2. We are taking this from here. As we say, to get the x-coordinate turning point, we just equate this to 0. So which is going to be squared. Then the y-coordinate turning point, which is minus 3 over 2. This becomes your solution. We are moving on to part A. 1. Then they are saying, hence state the coordinates of the turning point. Hence state the coordinates. Hence state the coordinates of the turning point of the graph of y. Hence state the coordinates of the turning points of the graph of y equal to 2x squared minus 6x plus 3. So they want the coordinates of turning point of this graph. So it therefore means the coordinates of turning point, to get the x-coordinate as illustrated earlier here, you just equate this part to 0. That is minus x minus that. If you equate that to 0, then the x value is going to be 3 over 2. Then the corresponding y value is going to be this part which is here, which is minus 3 over 2. Alternatively, it was possible that instead of stating, you can calculate. But we have used this method already. So minus b over 2a, we get that one. Then y, we get that one. Let's go to the second part there. Then they want you to state the sequence of transformations by which the graph of y equal to x squared is transformed into the graph of y equal to 2x squared minus. If we are to check the graph of y equal to x squared here, the first transformation, as we can see here, it means we have, number 1, we have to substitute our x by x minus 3 over 2. And we know that once we substitute by x minus, it's a horizontal shift. So, but where are we going? It means we are going to the, it means we are going to the right. Since it's negative there, it means it's a horizontal shift going to the right. That is what is started. So, a sequence of transformations, number 1, there was a shift to the right by how many units? Shift to the right by 1.5 units, by 3 over 2 units. Then number 2, if we check after the shift, we put the 2 there. The 2, which is that A, it shows a stretch along the y-axis. So there was a stretch along y-axis by scale factor by scale factor 2. If we check this one, it takes this form f x plus or minus a for horizontal shifts. If it's plus, it's going to the negative. If it's minus, it's going to the negative. You'll be coming from fx. Then this one, it takes this form a f x, where the fx, we were now having this graph, then we multiplied by 2. So it means it's a stretch along the y-axis by the scale factor 2. Then the last set of transformations that was there, yeah, if you are to check, is this part whereby it's a shift upwards, it's a vertical shift. A shift upwards by how many units? A shift upwards by, oh, because we are having a negative, take note, it's a shift downwards, not upwards. It's a shift downwards of how many units? Of 3 over 2 units. So, in this form, we are saying we are having fx plus or minus. Take note here, what was added or subtracted in the bracket here. It is going to talk about the vertical shift. If it's a plus, it's an upward shift. If it's a minus, it's a downward shift. So the three sets of transformations is shift to the right by 3 over 2 units. Then you stretch along y-axis by scale factor 2. Then lastly, it's shift downward of 3 over 2 units. Then the last part of the question is saying find the value of k for which the equation, this one, has distinct roots. So it means we are supposed to take this equation, but take everything to the left-hand side. So the equation is going to be 2x squared minus 6x. Take this one again with x, so it's gonna be minus kx plus 3. We have a 3 there. Then take this one to that side, minus 1 equal to 0. This is the last part of the question. This one was A2. This one was A1. So this one is B. Then you write it as 2x squared minus, it can be 6. When you factor out a negative 1, it becomes 6. Here it becomes plus k x. Oh, okay, it's fine. We can leave it that way so that we can leave it without factorizing. Take it as minus 6x minus kx plus 3 minus 2 is minus 1 is going to be plus 2 equal to 0. But they are saying for it to have distinct real roots. So for this to have distinct real roots, we will be concentrating on the discriminant, that part which is b squared minus 4ac. So what is it that must happen? It means the b squared minus 4ac must be greater than 0 for the roots to be distinct and real. Must be greater than 0. So what are we going to do now? It means we have to simplify that so that we get our solution. B is what? From the format ax squared plus bx plus c. What's b here? B is representing the coefficient of x. So what's the coefficient of x here? The coefficient of x, we are having the minus 6, which is the coefficient of x. Then we are having again minus k, which is the coefficient of x there. So b squared minus 4a. What's a? A is the coefficient of x. What's the coefficient of x here? Is 2. Minus 4a. C. What's the c? We go and check c is the constant. What's the constant there? Is 2. So it means this must be greater than 0. So let's solve the inequality. If we are to expand that, it means that squared is gonna be 36 minus 12 k plus k squared. Here is going to be minus 16 is greater than 0. Then writing this in standard form, we are going to have k squared minus 12k plus 20 that is greater than 0. If you are to check this one, you can use the quadratic formula or the factors. If you are to factorize here, we are going to have k minus 10, k minus 2 being greater than 0. Then from there we can get the critical values. The critical values are what? In this case, the critical values are 10 and 2. So if we are to use the graphical method, remember there are many methods. You can use table values or whatever. But if I were to use graphical method, it means we have a sketch of this graph. Since k is positive, it will be something like this. Then you ask yourself where the graph is saying k is greater than 0. So we want where our graph there is greater than 0. Here are our critical values. Here we have our 2. Here we have our 10. So it means the k is less than 2 or the k is greater than 10 for us to have distinct real roots. You can use any other method. You can use that one of making table of values to solve the inequality. You can use number line, whatever method that you are comfortable with. Thank you very much.